Okay, let's look at a related rate problem. Here the figure has a circle and a square inscribed inside of it. And it tells us that the circumference is increasing at a constant rate of 6 inches per second. So we have dc dt is equal to a positive 6 inches per second. And it's telling us that as the circle expands, the square also expands to maintain the relationship to the circle. So they want us to find the rate at which the perimeter of the square is increasing. So the perimeter, dp dt. So we have to find an equation for the perimeter of the square. Well, it's inscribed inside of here. Actually, I have this drawn backwards. It says that it's the other way around. The circle is inscribed in the square. There we go. Makes a little more sense. So we have our radius here, right? Well, if it's inscribed in here, the length of each side of the square is going to be 2 times the radius, right? And that's 2r, and that's 2r, etc. Well, since we're looking for perimeter, the perimeter would be 2, 4, 6, 8 r's, right? Okay. So what is the derivative? dp dt is equal to 8, and we just took the derivative of this, right? dr dt. Alright. Well, what do we know about the circumference? The circumference is equal to 2 pi r. Okay, sorry about that pause. So we have our dp dt, which is what we're trying to solve for, but the only thing they gave us was dc dt, and we know that the circumference formula is 2 pi r, so if we take the derivative with respect to time of the circumference, it turns out to be 2 pi dr dt. And dr dt was a missing value over here. They gave us that 6 inches per second is dc dt, and we identified that right here, right? So we know that 6 is equal to 2 pi times dr dt. So solving for dr dt, it's equal to what? 6 divided by 2 pi, or 3 over pi. Okay, so this is dr dt, so we're going to put in that value there for dr dt, so it's equal to 8 times 3 over pi, which is equal to 24 over pi inches per second. Okay. Let's take a look at part B. Part B says, at the instant when the area of the circle is 25, so the area of the circle is equal to pi r squared. They're telling us that it's equal to 25 pi inches squared. And we want to find the rate of increase in the area enclosed between the circle and the square. So we want to find that this area here, it's increasing as the circle and the square increase. So this is going to be the area of the square minus the area of the circle. Alright? And remember that the area of the square is going to be what? 2r times 2r, or 4r squared. And this is going to be pi r squared. Alright? Okay. So what can we do here? Let's take the derivative of the area. Well, let's write the equation again. So we have the area is 4r squared, that's the square, minus pi r squared, and that's the circle. So the area changes is equal to 8r minus 2 pi r, and we took the derivative of r, so we need to know dr dt, and this is 2 pi r dr dt. Alright, so this is what we're trying to solve for. We have a variable here, and we basically have a variable here as well. So we have two unknowns right now. Well, we know that the area of the circle is 25 pi square inches. So if we solve for this, we divide by pi, and let's do it over here. We get area is 25 pi equals pi r squared. Divide by pi, divide by pi, and we get the radius squared is equal to 25. So it looks like our radius is equal to plus or minus 5. Well, we can only use positive values when we're measuring. So let's plug in. We get 8 times 5, or 40, dr dt, minus 2 pi times 5 dr dt. Looks like we could factor out a dr dt here, and we get what? 40 minus 10 pi times dr dt. Okay. And how are we going to fix the dr dt? Okay. Well, if you recall in the part A, and we can still see it right here, since the circumference is always increasing at a constant rate, we used it to find that dr dt is equal to 3 over pi. So we do have that value available for us. So we have 40 minus 10 pi times 3 over pi, and that would give us the change of this area. So let's pull the calculator out and see if we can come up with a value for that. So we have 40 minus the 10 pi, and we're going to multiply that by 3 over pi. Oop. 3 over pi, and we're going to get a value of 8.197. So 8.197 area is going to be square inches per second. Okay, so you can see that this problem could get kind of complicated. Make sure you're legible in your answers and that you remember that you can use parts from A to solve B. Okay.